question 3 from our review packet for this unit on functions. So we have the graphs of those two functions, and we're looking for the values of m such that the two graphs have no intersection points. So what we're really looking for is where x squared, sorry, this is going to jerk me around, x squared equal, or x squared over x minus 3 is equal to, thank you so much, is equal to mx plus 3. Okay, so we're saying that they're not equal, because if they have no intersection points, then they won't be equal to each other. But I'm going to use the fact that we're going to use that they're equal to be able to solve this. So this tells me that x squared is the same as m, and if I just multiply this over by that side, that is the difference of two squares, x squared minus 9. So I'd be left with x squared is the same as mx squareds minus 9m's. So then I can rewrite this, because in order to solve, it needs to be equal to 0. So if I take x squared away from both sides, I would get m minus 1 x squareds minus 9m is equal to 0. So we're looking for when it doesn't equal 0, or in reality, we're looking for where it's going to be imaginary. So what I'm going to use in order to solve this is I'm going to use the discriminant. And I'm looking to use the discriminant when the discriminant is greater than 0. Sorry, I'm strictly looking for when the discriminant is less than 0, because when it's 0, there's no intersection, it doesn't equal 0, so that'd be where we're at. So if I use the discriminant, which is negative b minus 4 times a times c. Okay, so if I have that, then what I would do is I just substitute in, I get 0 minus 4 times m minus 1 times negative 9m. Simplifying that, I would end up with, what is that, negative 4m plus 4 times negative 9m's. That would give me 36m squared minus 36m's. Okay, so now I'm looking for when that is going to be less than 0. Right, so if I just do my factoring, I would end up with 36m times m minus 1 is less than 0. So my options, because we've done a little bit of division here, are that 36m is less than 0, or m minus 1 is less than 0. If we do that, I would have m is less than, well, m would have to be 0 in that case. That would make that less than 0. So m is 0, sorry. And the other option when this happens is when m is less than 1. Now, to make that happen, because any value that would work like that, similarly, we have to look at where 36m squared minus 36m is greater than 0. Now, the reason why we have to check that is because we're taking square roots and things like that. So we have to do kind of a compilation of these two things. What that would give me would be 36m, m minus 1 is greater than 0. So I'd get m has to be greater than 0 in association with m has to be greater than 1. So now what we have to do is we have to combine these two things together. Looking at this, this value here, so both of those, m has to be less than 1, covers both of those. And here, m has to be greater than 0. As you can see, my iPad has screwed up, so it's not working correctly. So what we end up having is m has to be greater than 0, but less than 1. So the values of m where there's no intersection is when m is between 0 and 1. I hope that's helpful.